I apologize for my pronunciation because I'm teaching in Mexico City. My English is terrible, terrible. Okay, so main subject of my talk is isometry group. Isometry group is group, I don't know how to say, preserving metric tensor. Metric tensor is like, so we must have metric tensor, and probably I should say G isometry. G is metric tensor, and the group preserving exactly this metric tensor. If you have two different metric tensor, Philip, there are two different isometric group, and every isometric group is a subgroup of general linear group. So if you change metric on manifold to metric with curvature, of course, every metric, Schwarzschild, has his own isometric group, but isometric group of different metrics are totally different subgroups of GL group. And Jerzy Kocik pressed me that they are isomorphic. But you know, metric tensor possess different symmetries. Philip, could be killing symmetries. This is Petrov classification of the metric tensor in terms of the group of symmetry. And of course, if the different metric tensor have totally different symmetries, they have different isometric group, and I don't like mention that they are isomorphic because this isomorphism is really irrelevant. They most important, they are different subgroup of the same group. Why I'm interested in isometric group? Because example is Lorentz group. This is basic fundamental group of the relativity theory, as is believed, and this Lorentz group is exactly example of the isometry group. But my talk will be about totally arbitrary isometry group for arbitrary metric, for arbitrary dimension, but motivation comes from this shown. What I'm interested in the following situation, that we have a river side. We have a river. River, with respect to river side, is flowing with some velocity. Is strong flowing. So this is there is a relative velocity of the river with respect to the river side. And suppose that on river there is some barge. It's okay, Jurek? Jerry, barge? Jerzy. Okay, and there is a velocity of barge with respect to the river. So this is, every velocity is relative. Velocity of one body with respect to the one body. For example, Gregory velocity with respect to Jerry is 0 because they do not move. But velocity of Jerry, Jerry? Greg with respect to me because I'm moving is not 0. Velocity is relative, and this was realized for the first time by Galileo Galilei. And this is most important concept of relativity of velocity of theory of relativity. So in my opinion, Galileo was most important person. Okay, then of course there is also velocity of a barge with respect to the river side. And the problem is how these three velocities are related. And if in elementary school we learn concept of addition. Addition. Could be addition non-commutative? as in your talk? Addition? Could be? Because we rather about non-commutativity, we rather think about multiplication. Multiplication is non-commutative or commutative, but addition usually, usually we apply situations that this is really commutative. So this in relativity theory, this velocity of barge with respect to the river side is called addition of this velocity and this. So this BS, this velocity of barge, is called to be first. Okay, I like as in all, because this was first velocity, and usually they put here this symbol addition of velocities, and here is B, velocity of barge with respect to the river side. Addition probably is better call this composition. We compose this velocity with this velocity, and the result must be expected to be velocity of the barge. So oh my God, thank you. And this composition, because every velocity has, for example, every velocity, this velocity river side is observer, because in respect to river side. And what is moving river. You are standing on river side and watching how a flow of water is moving. So we have always, so every relative velocity has a source or observer. Observer is S, river side, and has target as what is observed, and this is just a river which is moving. So every velocity has this two things, and we can compose if and only if this velocity with this velocity, if the if the source of this velocity is the same as target of this, because you cannot compose velocity of river respect to the river side with velocity of car with respect to some plane. It is totally different story. So this composition is partial. Only some pair of velocities are composable, and you can compose. So maybe, I have this color. So I don't like this addition. So problem is how relate these three velocities for the case of the finite speed of the light, because in case of the infinite speed of light, we have no problem to understand this. And formula that you can find in any textbook is the following. Where I put this formula, because I will need many. The aim is to derive this formula. So maybe I put here this scalar plus this okay, it's the scalar product of these two velocities divided per c square. This is scalar product of two vectors, velocity is vector, divided by speed of speed of light. Here is this composition of these velocities. I wrote correctly. Yes, correct. Okay, and I have probably here problem or no with space in blackboard. Plus, here comes gamma BR. Oh, I will tell you what is this coefficient gamma, important coefficient gamma, and here is scalar product of BR, and here is part, okay, VRS, and here is wedge product, Grassmann product of BR. Okay, we found. So this is a Grassmann product. So it's B vector that Grassmann invented in 1844 by vector, and okay, in a product of vector with bivector is again vector. This is derivation of Grassmann algebra. So we saw these are two vectors, sum with this vector. This is scalar, and this gamma, every velocity possesses his own gamma, 1 minus B R C, okay, square is equal 1. Okay, this is this. So you see that if speed of velocity is infinite, we don't have this term. The scalar is 1. We have usual Galilean addition of this. What property this velocity has? So first I like, because almost nobody is interested from what axiom, assumption this velocity, this formula comes. I'm interested. Somebody is interested? Nobody.
Yes, no,
People believe in any formula and every book without asking why this comes from. Why it comes from. Okay, so first part of my talk, I like to say properties of this. This is binary operation, that if you have two vectors, you can construct a new vector according to this formula. What properties this formula has. And after, I don't know if God allow me time, I will exactly derive this formula, if not today, maybe tomorrow, or maybe after tomorrow, completely, if somebody is interested, okay? Because I understand perfectly all assumptions, all axioms, everything from what this formula follows. This is fundamental shown. Is fundamental or not? For understanding space-time or relativity or something. So, if a barge is moving with velocity this, then respect to the river, then river is moving with velocity. I just switch index. This is velocity of the river with respect to the barge. Okay, and here is velocity of river side with respect to the river. So every velocity has inverse, and inverse of is by definition velocity just opposite part. And if we if we compose, so first there are three problems with this formula. Okay, no problems, just facts, three facts. Okay, three facts about which you never can read in no one textbooks. Never. Don't sleep. I'm not sorry. Great. No. First problem is this inverse must be involutive. That is what we in fact suppose will be strange, that this inverse, this will be no double inversing, you're getting again involutivity. Another property is that the inverse velocity square must be the same magnitude of okay, must be the same. Cannot be that magnitude of, they are different. And normally, if we compose this velocities, here is very important point. Please don't sleep. Everybody sleep? No. You know this story. If you compose two maps, and you look for inverse, this is always anti-homomorphism of the operation inverse. So if we first compose this with this, so we're getting okay, and look for the inverse, and if we first may make inverse, so inverse of this is this, and compose this. How I composing? I putting okay. So I must put here v r. This is indexes. I'm not good in this. So okay, this is inverse of this. Must be here, and if I sum with inverse of SR, what I'm doing, I'm composing this with this, and I'm composing this with this with this, right? So this is inverse of this. I should expect equality, because this is inverse of this, and this is inverse of this. Or maybe I should write better. It's clear. I am expecting, yes. But you can see here, because this operation has, I should probably add that barge, with respect to the barge, has velocity 0. Or barge, yes. Every body has velocity, river, respect to the river, has 0. This 0 and this 0, they are different zeros, and the same river side has velocity of river with respect to the river. This is 0 with respect to the river. Because normally we think about inverse with respect to the unit. How we learn in algebra. You have binary operation. You have you check if this is a neutral element, and then you are looking for inverse for neutral element.
With respect to the neutral element?
Yes. So you have neutral element here that if you have v, if you add for S is, you have two-sided neutral elements. This is 0, added with this with the same, yes. And respect to this neutral element, if you are looking for the inverse, you see that the inverse of okay. This satisfies this condition, that inverse must be collinear to every velocity. This collinearity of the inverse. So this is inverse to this. This is inverse to this. Because if you put here that this is inverse to this, this is going to be 0, and maybe I put here that inverse of RS, okay. Now I will not keep it as a secret that this is just exactly minus, what I should say, RS, okay? It's correct? Or I'm wrong? Inverse must be this, right? Yeah. But what happens here, I have red color, that and normally in all formula is given. This formula possesses neutral elements, possesses inverse, satisfying exactly, the only inverse is collinear with exactly this condition. And now if you, according to this formula, add first you add this, and then add this, you're getting that they are not equal. That inverse of first summation do not satisfy condition of reciprocity. I taught this in Chicago. I taught this in Waterloo. Nobody worry. Nobody worry. Because axiom of relativity is that inverse of velocity is reciprocal. This is reciprocity. This is all in books. It's called principle. Principle, they called Einstein principle of reciprocity. Einstein supposes. But of course, if you have this expression, this is the only solution. So this means that every inverse of every velocity must be reciprocal. But if you add first two velocities according this formula, you get that inverse do not satisfy this condition. Inverse is not reciprocal. So this is mathematical terrible contradiction, because they assume that every velocity is reciprocal. Then you compose only two velocities, and get that this composition is not reciprocal. Who worry about this? This was discovered by Konstantin Mokanu in 85. So it's 30 years after Einstein died. And he was not able to publish this. Nowhere, because all journals of foundational physics, they cannot accept this, because this is contradictory to relativity theory. Was not able to. And now, do you mean that somebody worried? I am alone. I am alone. Second problem is the following, that if we add, maybe I should not say problem, because all referees said there's no problems. Only not educated person not understand simple theory. So I should not use word problem. No, this is really a terrible contradiction. That formulas that have such inverse after first addition, they do not satisfy this reciprocity condition. Second is that if on the barge there is some sailor is walking with velocity of, oh, I don't know. Should I put some, what I should put, another name? Dog. Dog. Okay, dog. Dog is walking with respect to the barge, on barge. So then, of course, we can compose three velocities. So we can compose, we have velocity of the dog, we have velocity of the barge, okay, of the river, okay, and how this is ternary operation. Okay, I will write here. No one textbook, no one book on relativity mentions these things. This is totally forbidden to mention. But I tell you. So if you, Greg, if you first, according this formula, compose this and after this, or if you compose first this according to this formula and then according to the same formula this, you are getting totally different result. This composition is non-associative. So sailor, because this is velocity of a dog with respect to riverside. So dog with respect to riverside possesses two different velocities, magnitude totally different directions. And this was discovered not non-associativity, this discovered Abraham Ungar in Iowa in 1988. And this was there was many conferences about this story in mathematical conferences on non-associative algebra. Algebra is non-associative, and they found that this binary operation is is quasi-group. Quasi-group is generalization of the group, that you have still composition, you have still neutral element, you have inverse, but composition is non-associative. This is called quasi-group. And if in special case of quasi-group, with this they call loop. And if you really are interested, I tell you that this composition satisfies two identities that has been discovered by this Russian people from Kazan. Okay. Is interesting or no? Real science, not false. Not false. So if you have, now this is totally, I don't know, but in this Ungar wrote 2 or 3 monographs, 100 publications about this enthusiasm. All this and this they call is beautiful. Sorry is beautiful. It's so beautiful for a mathematician that is a lot of to investigate. So they do not see no one mention contradiction. First is contradiction, terrible, mathematical. Secondly, is totally not acceptable by reality, because in reality no, it's not possible that one body respect to another body possesses two velocities. But Ungar wrote, no, this is okay because it's Thomas rotation. This is okay, perfect. Dog has two velocities. So they accepted this. So if you have, I'm using a graphical presentation of binary operation. So this binary operation, if you have the V and U, I'm writing that here, that this is input. Input, there are two vectors, output is composition of the two vectors. So if you have three vectors, okay, so input, here is output. But please, after this talk, do not say nobody that I taught this right to you, because it will be not good. So if you have one velocity, another velocity, third velocity, and here is composition, here is braid, cross, here is another, you composing this is duplication. You duplicate the same velocity twicely. Here is another, this one, and here is, okay, maybe I will not write more such terribly complicated diagrams. I have here two such diagrams. Here is 1, 1. This is called ball identity, left ball identity. There's another Richard Brook identity. And this Russian people, last 10 years, they prove that the only binary operation that satisfies the two identities is exactly this finite, I call this finite light speed composition. I do not like relativity because this word is really, what is finite. Okay, because this generalization of Galileo comes from the two terms. Two terms, yes? And no, okay, maybe I should not tell. Okay, there's maybe third fact. You know that the most important ingredient of relativity by Einstein was that time is relative. That different reference system, so riverside and water, they have a little different proper time. So the different proper time means that proper time of river is proper time of riverside. This is Grassmann product. That this is cannot be zero if they move respect to each other. So this is just superficie of simultaneity as seen from riverside and simultaneity as seen from river. Simultaneous event. And therefore, we can imagine that riverside, spoke to the riverside, must be tangent to simultaneity of the riverside, because all velocity, what is measured, you don't believe me, but a velocity that you observing is observing always in your presence. You cannot measure velocities day after, previous day or day next day. All velocities are in tangent to simultaneity of the observer. But if for Einstein there are really different simultaneities, therefore you know some assumption, because this is assumption of Einstein, that velocities of collinear, no, this is terribly contradiction. No, three such contradictions. One is reality, two is mathematical contradiction, but theory is admired as good theory. Now I know how much time I have to start to derive this formula. I need 3 hours. No, maybe not, maybe 2. But how much time I have?
Like 6 minutes, unfortunately.
6 minutes?
6 minutes.
So maybe we, no, really, if somebody is interested, I perfectly understand this, Philip, very deeply. Everything, how I will derive this formula exactly in Thursday, after talk of, okay? So I'm inviting everybody for derivation of this formula. But now you have motivation. And I will also show you how I propose to resolve this. There's 3 problems. There is an alternative theory, different rival theory of relativity, where there is no such contradictions, okay? And Thursday.